All right, y'all. Today I'm gonna show you my Blackjack program. So, Blackjack, otherwise called 21, is gonna be a popular card game in casinos all over the world. The objective is gonna be to beat the dealer's hand without going over 21. My Blackjack program implements the following features: the multiplayer option, the betting system, the keeping track of statistics for the players, allowing for multiple rounds, and handling aces to benefit the player or the dealer. On top of what we already have implemented as a class. So on the screen here, you can see two players named John and Jacob running through a game of blackjack through my program, and the game asking John and Jacob individually different questions based on the game state. Switching gears over to focusing on my code, my program features four different classes. There's a card class, a deck class, a player class, and a blackjack game class. In designing my program, I decided to make blackjack game class contain most of the logic related to the blackjack game itself. And opening this, you'll see the first of my main algorithms named play round. The problem that I ran into early on in my programming of blackjack was play round containing a bunch of logic, and it was a bunch of lines of code, and this made it super massive, and this was incredibly inefficient and caused a lot of problems. So I had to break it up into different parts. So the play round method is the key component of my blackjack game, responsible for executing a single round of gameplay. So here's a breakdown of what's going on. So the prepare round function is going to be initializing the game state for the round by calling the prepare round function and resetting the player's hands and the dealer's hand and clears any previous bets placed and shuffles the deck so that you're not getting the same predictable amount of predictable cards. And it's also going to take the player's bets where the players are prompted to place their bets for the round using the take bet method right here. And this method ensures that each player places a valid bet within their available balance. Here, I constructed a while loop that will continuously ask the player to input a bet. And if the bet's not valid, it's going to continue looping right here until the player does submit a valid bet, which will go into dealing out player cards. And here I show you a couple of examples of the player inputting an invalid bet and my program rejecting them and continuing to ask for a valid bet, specifically within the 100 and 0 range. Once the player inputs a valid bet, the program goes into deal initial player cards method, which deals 2 cards to each active player and stores their total once it's calculated. Once the player receives their cards from the program goes into deal dealer cards, which deals the single card to the dealer and calculates the dealer's total. So right here's where the string prints where it tells the player the suit and the rank. So from there, it goes straight into handling the player's turn, where the players told their what cards they have and the total as an integer, and the player is given the choice to either hit or stand. So if the player chooses to hit, it's going to ask the program's going to ask, is the total less than 21? And if it's less than 21, it's going to loop back to the player's turn so that they can either choose to get another card, or they can either be happy with their card with the total points that they have. And if they keep hitting, their total is eventually going to go over 21, and the program's going to go straight into the dealer's turn without giving the player the choice to either hit or stand. Once the players have all finished their turns, the dealer's turn begins, and then from there, it's going to determine the winners for each player. And then it's going to also check if they want to play again. So for both of these algorithms, I'm going to go into more detail with. But from here, the program is going to check and see if there's any active players left. If not, the play round function ceases. It's done. And then if there are active players, then it'll loop through play round once more, and the game will continue playing. So the determine winners algorithm is responsible for evaluating the hands of the players against the dealer's hand and determining the winners of the round. So before comparing the player's hand to the dealer, there's a few things that we have to check. A few really simple, basic stuff we need to get out of the way really quick, because there's some simple questions that would save a lot of time. So we want to make sure that for every player, we're checking if they're an active player, and if not, we skip them. But if they are, we want to see if the total is more than 21, because if it is, then we can just simply say that they busted and increment the bust for that player and move on to the next player. But if their total isn't more than 21, we want to check if their total's equal to 21 as well, because that would mean that they instantly get a blackjack and they won. So here we're asking if the player's total is closer to 21 than the dealer. And if it's yes, then that's the objective of 21. We get a win for that. And if not, we ask, is the dealer total equal to the player total, because we want to see if there's a tie. If there is a tie, then we would treat it as a tie and increment the amount of ties that the player gets in their statistics. And if not, then we're assuming that the dealer has a close value closer to 21 than the player, which means that the player loses and they get a bust on their record. And we repeat this for each active player that participated in the round. And as soon as we go through all of the players, the determine winner is finished. So looking at the data types of my program, I have 3 data types. So there's a vector data type that holds the players. There's a set data type that keeps track of the active players. And there are maps that keep track of certain integers that that are associated with the player. So with the reasoning behind using vectors and sets was to compare the two throughout the entirety of the running of a blackjack game. So if you look through my program, you can see that this line of code will be repeated throughout the game, because the game is constantly checking to see if the player that is located in the vector is also located in the set, because the set data type was implemented to have something that I could easily change and easily delete certain players out of the game so that I can keep track of active players and remove players when I needed to. As for the map data type, I have two different maps. So there's a bets map and there's a player's totals map. Both of these are going to have the key associated with them be the player that places the bet or the player that has the cards that are equal to the total. So here we see an example of the bets and the player's totals map being used to in the prepare round method to reset the bets and the player's total. So here is an example of me using the bets and the player totals maps to reset the bet and the total of the player associated with each. So for every active player, I reset the bets and the player's totals map just using the player's name that I received from the player vector right here. And this is the reason why I chose maps as my third data type, was because it was really easy for me to retrieve this data and it's really efficient. So a couple of things that could definitely improve my blackjack game would be to number one, improve the visibility of the game. As I'm playing, I'm seeing a big wall of text just kind of like thrown up at me, and even something like a new line in between each round would be a huge difference in visibility and human readability. Uh, Another thing is adding a feature that allows players to join um, on their own instead of, because the way it is right now, the players are created in the main function and have to be implemented manually with the amount of balance that they have. And this is obviously not something that we don't want to have to do each time that we run the game. Uh, Another thing that we could probably add to the game that would increase the quality would be to add in something that the players can spend their money on. And that way, it actually feels like you're kind of working towards something instead of having like a big number go up and up and up and up and not be able to spend your money on anything. So yeah, those are the things that I would do to improve the game. Let me know if you have any other ideas or any other questions. Thank you so much for your time, and I will wish you guys the best of luck in the rest of your semester.